Now it's right. Okay, so I'm going to give a general introduction of the topic that we are going to address today, and then we will start in a collaborative activity later on. So, publicity. I suppose that many of you, or the majority of you, have started designing your the perspectives of your professional life. And normally, when we finish studies, I mean, maybe the immediate thoughts are looking for a job. Yet there are other alternatives that can be interesting. And of course, this is continuing your studies. I will touch a word on this because this is something that sometimes is not considered because for utilitarian reasons. Yet if you are thinking about continuing your studies, first of all, I vividly encourage you to consider studying abroad. And of course, I mean, Europe is an interesting destination, but if I can advise, I would look for the States to at least for a master, and then eventually think about going to Europe for other studies. And that's one thing. And the other thing is that it is possible to get out of the defined and classic programs that are promoted today. And in this regard, I want to drive your attention about an example of things that can be done associated to data science, but very in the underground, I mean, out of the predefined ideas that we have about data science. And for that, I decided to talk about the work of a person who is, she's finishing her studies in NYU, a very reputed university in New York, and they have an extraordinary data science program. And this person is working with under the topic of responsible artificial intelligence. And beyond the fact that she is a computer scientist, a data scientist, she's also an artist. And so all the work that she's performing around responsible AI is technical, but it's also around comics. And so she produces books of comics talking about responsible AI, and well, of course, she does classic data science too, and she combines both. So the interesting thing is that she combines art and data science within her research, PhD research. So if you are curious, you can go to her site, and she shares, of course, on Instagram, etc., the artistic production. And then, of course, you can also have a look at her publications. She has many interesting publications with her advisor. And in that way, you can also have a look at the cool program of NYU regarding data science and machine learning, etc. How do I manage a PhD and a master? Well, if you are interested in continuing your studies, please contact me. I can remember that in Mexico, we have the CONACYT with a very nice funding program for Mexicans. So that's one thing. Of course, there are also a lot of possibilities now around provided by universities and open positions in many different places, so that you can be hired as PhD and master students in reputed universities. So if you are looking for those possibilities, you can eventually contact me. I have a lot of information about that and about opportunities that you can have, including working partially in industry and doing studies. So there are a lot of nice possibilities today. Okay, so with that in mind, let's continue. So the very last session of the lab, I wanted, particularly in the lab, I wanted to devote it to drive your attention towards ready-to-use solutions that deal with massive data, greedy algorithms, and data science problems. Okay, so they deliver the solutions either on very developed portals for people that are not willing to develop a lot of code and a lot of technical matters, and that want to concentrate on data-driven problems. But they also behind provide APIs and very interesting infrastructures in order to provide such service. So I want to drive your attention, of course, on the possibility of using these tools in order to address data-driven applications, but also to the fact that it is possible as computing systems engineers to work behind the scenes and contribute to the development of these important infrastructures and create the such services on the cloud and on many different infrastructures. So this is the message of this session. And well, and all these tools are intended to manage big data at scale, okay, and on specific target architectures, and particularly on the cloud. So in order to understand the type of functionalities that we can seek in this type of infrastructures, we have to go a little bit behind the scenes and remember that when we are dealing with data, with the different properties that we can associate to big data, there are different access patterns, okay? And we can identify 5 of them, which are the most general ones. Of course, there are hybrid patterns, etc. But these are the 5 that we can consider and that are, as I said, behind the functionalities of infrastructures that are devoted to provide data management at scale. The first of all is the document transactional access pattern, which means that you have documents stored in any storage solution, as those that we have considered and studied in the lab and then in the regular course. And you will provide different transactional guarantees in order to deal with these documents. Yes, Mauricio. I think that I can.
Yes.
Yes.
I have a question, teacher. Do you are showing something in the screen or?
Yes. And you are
Okay.
not.
Yes, we can not see.
And I'm watching the second screen, and I'm just talking like that. Let me have a second try. And now you can, now it's great. Thank you for telling me. So what you saw normally was this, you have to see. Then I went through this, and now I was here. Okay, so, and I'm in the very left side of the screen. So documents managed under different transactional guarantees, and that now you are experts on that because you have done your polyglot persistence exercise. You have thought about the guarantees, the way they can be associated. So this uh, reasoning about how to associate document storage or any other data structure storage associated to guarantees is a data access pattern. Okay, and this is known as document transactional pattern, even if we are not necessarily talking about documents in the sense of MongoDB documents. Okay, so it's data, transactional data access pattern. Then we touched a little bit about a second pattern that is merely related to archival. Okay, an example that we saw of this archival method was the solutions that we saw in Kaggle. Okay, so in Kaggle and similar solutions, what you do is you have more or less raw data in a specific format. Remember that it is different to talk about data models and formats. Formats are just a digitalized representation of some content. And then data model is representing the content, right? So if we do not want to care about design, we just sense and collect the data and then put them in a distributed file system, we are talking about the document archival access pattern. And we also saw in a very superficial manner, but we saw that there are some archival solutions. I showed you Atlas, for example, which are solutions where you archive your data and you tag it with specific metadata so that you do not have a swamp and that you can eventually explore this archived data. Third access pattern that we have also studied here is the MapReduce pattern. So in fact, what happens is once you have data, you want to process the data, and you process the data normally through algorithms. And so these algorithms are greedy algorithms, and when you have greediness and data volume, you need to use specific programming patterns in order to make sure that you do these tasks in reasonable times, and in order to really exploit the power of these MapReduce or these parallel models, you reason about specific target architectures. And do you hear that like a music?
It's like a notification.
Yes, but it's in my computer, right?
Yes, probably yes.
Well, I will not care about this. Please, please. Thank you. Okay, so that's the data processing pattern related to greediness. Remember that there is not only volume, but that there is greediness that makes pertinent to use this kind of pattern. If you have a lot of volume, but you do not apply greedy operations, maybe you can get away with a non-parallel model on a more classic target architecture. So it's important that you associate problem and pattern. Then, of course, that's something that we didn't study here because you had already studied before. Relational transactional patterns are one of the most used, and it's a reference pattern, and something that we didn't have time to study. So I'm honest with you. The lab is too short and the course also is too short, so I decided not to go into streaming aspects, and also because you are having now the IoT course, and so I assume that there you are studying streaming management, etc. But it is important to know theoretically that this is an access pattern. So all the necessary strategies that you develop in order to reduce the impedance mismatch between the fact that streams are continuous production models and are guided by continuous production models, and that you have a discrete computing system. So there are many strategies that you need to adopt in order to reduce this impedance mismatch, and I am sure that you have seen that there's windowing solutions in order to do that, and have the illusion that we are really dealing with streams. So that's the kind of patterns that we have to implement in order to deal with continuously produced data that we know as streams. Okay, so the question when we think about engineering and about infrastructures is, what are the right infrastructures that can implement these data access patterns so that someone that wants to deal with them can do it in an organized manner. Okay, I'm not saying that this is intended to be used by final users. It is engineers, programmers that are the users of this kind of patterns that are normally grabbed in target infrastructures. And so if we have the other cut and we think about how solutions within infrastructures can be delivered and that implement these kind of patterns, so we can have a look at the cloud data management stack and see which are the type of services that are available in cloud solutions in order to implement these patterns and use these patterns for target solutions. And this is something that we saw recurrently in this lab, is that, of course, in the very lowest part of a stack, we need distributed storage. And so it is possible to have different services providing this distributed storage. And if we think about this, we would be talking about more or less this and this. So these distributed storage solutions are overlapping these two patterns. So there are more they go more into the archival perspective if we are talking about file systems, and some of them have ensured specific transactional guarantees, particularly duplication, to ensure availability. Okay, so we are at this level of the stack, so very close to infrastructure, very close, but not infrastructure. Okay, so this is platform as a service. Okay, and so these are the guarantees that we normally can expect from a cloud solution that addresses the patterns that I have enumerated one second ago. So they ensure fault tolerance, availability, and scalability. Then we also, I mean, this is the very the minimum service. Okay, so then we have seen that another incrementally we can go further into the kind of functionalities that we can access to and the guarantees. So we can think about infrastructures that provide us with functions that can help us look up data here. Okay, and so we have seen NoSQL systems, for example, that provide this kind of lookup services in order to access to this distributed data. Then we also studied, and well, of course, in the historical moment that we are, NoSQL systems are among these two levels. Okay, if you're talking about the kernel, they are here, but then of course the market has done its work, and now they provide operators that can help us do more complex operations, and that can combine data processing and lookup operations. So if I go back to here, they are more or less here. Okay, so you have relational in the sense of being able to have operators that can help us do querying much more than looking up, and then the aspect of processing when we perform aggregations, when we perform other types of data processing operations that are more related to the MapReduce pattern. And then something that we didn't explore a lot here, because I really focused on engineering much more than high-level solutions and database solutions, again, because I suppose that you have studied that before. It is possible to have declarative solutions. And so it is possible to develop high-level languages in order to that grab all these underlying levels and that provide comfortable ways of expressing queries by at a high level support. And then you have individual users and applications here, but in this course we didn't think about them. Then just a kind of reminder about the existing solutions that you can find in the different levels. We have been using Hadoop distributed file system, but there are others. Okay, so I talked about Google File System, which is not open source. This is why we didn't use it. And then there are other solutions like CloudStor, which is also popular. Then these are distributed file systems. Normally, these file systems are master-slave systems. Then again, we would need only a course for going in detail into that, but there's Amazon S3, which is a very popular storage solution, and that's also available today in the market. And then there are other alternatives with regards to the type of architecture that we consider as reference architecture. So all of these here are, well, I said my master slave, coordinator, worker architectures, and then here Amazon Dynamo is a peer-to-peer file-like system. So you have these solutions. Then at the structured data system level, where we did many alternatives, it is important that you know that if you remain in a more advanced use of NoSQL systems. HBase, for example, is very, very popular. It's a columnar solution. Again, I didn't went into columnar because columnar are complex things to do, and I wanted to do other things with you and reason more about infrastructure and architecture. So I decided not to go into these matters. There's also Cassandra or Amazon SimpleDB. And then here that we used a lot and we worked a lot with Hadoop MapReduce as an engine to execute MapReduce programs. And here I didn't enumerated this, but there was also Spark that we also have been using it both to show the processing, but also to show how to deal with architecture matters in the cloud. And then here, well, there are many declarative languages. This in a data science course, for example, and data exploration course, we would have a look at this. Okay, so again, this was not the spirit of the course, and this is why we didn't went into detail. But it's important that you know that there are these SQL, in fact, like languages that are useful in order to express complex queries that rely on these underlying levels in order to be executed. But there are other ways of having a look at the problem, and this is, I'm coming closer to what we are going to experiment today. You must know that, well, in knowledge that you know because you've been in the market for now for a while, there is departmentalization of disciplines, okay? And within computing science, there is also this departmentalized way of understanding subdisciplines. And so when we talk about this kind of solution, it is more the distributed systems community that has worked a lot, and of course architecture community that has worked a lot on this type of solutions. But there is the database community, and the database community, when all these things started to appear, now they are more or less interleaved, but at a certain moment they were very independent. So the community started to think about alternative solutions, more inspired in the database management systems architectures, in order to figure out whether it was possible to provide a new version of a DBMS that could integrate this kind of stack, but in the way we are used to see it in a database management system. So with a lot of backend solutions that make it very easy and very externalized option to deal with data. And well, today this solution, the one that you have on the screen, is has been consolidated, and the name of the solution is Asterix. And Asterix was born in academia, in the group of a very important person in the database domain, Mike Carey, and they provided and they proposed a layer-based architecture called a big data stack. Okay, so now the idea is that you do not consider a closed monolith as the DBMS. You are going to reason about a stack of layers that you can access depending on the type of data processing and data management requirements. Okay, so that's something classic. That's something that you should know from your database course. Behind any DBMS or any storage solution, there is always the distributed file, well, a file system. and the operating system. Okay, so this is the kernel, and then you put layers on top of it in order to deal with your data. So they adopted the same strategy there, but now since it was distributed, so they had the idea that they rely on a distributed file system, and then they added layers of different types. Of course, there was the Hadoop MapReduce layer together with a data flow. So it is as if they had combined Hadoop MapReduce with Spark. Okay. So why? Because in general, when you deal with data, you deal with the control flow and the data flow. I believe that when one of the exercises that we did, and I think that I have questions from some of you asking me, well, finally, what is the difference between the control flow and the data flow? Because I find it very difficult to see. Okay, of course, because normally in the type of programs that we build, both are interleaved. The control flow says the sequence of operations that a program must execute, and the data flow determines the interdependencies of the I/O or data in the I/O that will help and make it possible to execute every operation defined in the control flow. So as long as you do not have the input data, well, the computer cannot execute anything, okay? So once the input data is there, then it executes. And then it produces an output, and as long as the output is not there, the next instruction cannot be executed. And now this is quite sequential. If you open the control flow into the possibility of being able to perform operations in parallel, what you have to make sure, if there are interdependencies, is that whether you really need the output of some activity, some operation, in order to execute the others that can be done in parallel. Sometimes you don't, and so these activities can be executed without waiting for the output of others. Okay, and this is what expresses the data flow. So the I/O interdependencies that are behind the control flow. So this is why they had this layer. And then there was HBase in the market. So either you program explicitly your data processing jobs on top of this layer, or you are just concentrating in the storage of complex structures with dedicated operations that can let you query them. So you can use this. And of course, there is an interleave situation between both, because behind the Hadoop engine, you can either rely on a distributed file system or on a NoSQL system, and this is why they are interleaved. And then at the top of the stack, you could have the query languages, dedicated query languages, in order to query and to process the data. So the input, the entry points could be at different levels, but the interesting thing is that since the layers were integrated into one stack, it was possible to define interactions in these levels that the programmer didn't have to care about. And this was this is a very principle of the VMS, and they adopted it for that. So if you're interested on Asterix, the seminal paper is 10 years ago, but the system is there. It is possible to download it and test it. And for example, if you decide to inscribe to Sigmod, normally MyQuery is there, and there are very often they provide demos and discussions on these stacks. So the final version is like that. So I don't know if you touch in programming language, the language Pregel. Pregel is a very famous function and logic language. So it is possible to write programs in Pregel, in IMRU, jobs, etc. So, you know, there are bricks of components that compose the stack, and then there is a possibility of having algebra. And remember that something that is very important that you never forget, algebraic representations of operations is interesting because behind you can optimize structurally. And this is very important when you deal with volume and with greediness. Okay, but then the world evolved and data science emerged, and now we are very worried about providing the right platforms so that machine learning operations can run smoothly using a lot of data with repetitive experimentations in order to calibrate the models and all these requirements and settings that are implicated in machine learning. And so the community started to move from these engines and stacks into much more complex environments that combine existing solutions but are really devoted to run models on top of a lot of data at scale, and also to maintain the result. Okay, so go into scale and into an industrial perspective. So almost, I would say, all the cloud vendors today provide this kind of complex infrastructures. So I'm going to use as reference the Microsoft one, but you can find similar solutions in Amazon, in IBM, etc. Okay, so Google. So the idea is that you want to go from data through intelligence into action. I'm not a Microsoft seller, okay? So it's like that, you know, the publicity. So in fact, you are going to have vertical and horizontal levels in your infrastructure. And we, in computing systems engineers, we are here building all these little layers. Happy to be geeky providers. So there are four main layers if you want to go from data into action. Action meaning applications that use the result of processing data and applying intelligence, etc., and having them on your smart devices, on your television, on your home, etc. Okay. The first layer is, of course, well, of course, here you have data collection, production, and etc. So here you have technology, but this technology is just feeding the systems with a lot of data. And then you have, you need to manage not only data, but information. And you have a lot of different services that you are going to use in order to start processing, archiving, etc., cleaning, exploring, etc., your data. And at some point, once you have, you know, crunch the data, you need to store them. And so you have big data stores that we have studied. So here you would have, you know, the exercise that we did in Kaggle, but in an industrial way. So we have the data that it was stored in the data lab, it was tagged, curated, etc. And then we perform statistic profiling and graph, plots and etc. All these is here, okay? And once we have a nice understanding of this and that we can stabilize the data, then in a more controlled form, it can go to these big data stores. And once you have them in such big data stores, then that comes the famous intelligence here that wants to not only explore and query facts, but it wants to see whether it is possible to extract knowledge hidden within the data. Okay, is it possible to, out of a set of observations, that I can model the behavior of birds living in the university, okay? Different species living in the university. I'm going to observe them, etc., and then I want to model their behavior. And so this is the third layer. So what do we have here? And this is what we are more or less going to have a look at, is a lot of algorithms, okay, essentially. And that you studied in artificial intelligence. Some of the algorithms need training. And the result of training is a model, and a model is the representation of a function or a family of functions. And this is presented in a digital manner, so in a program, and all this lies here. And here you can even see Hadoop, and you can have stream analytics, so everything that is necessary to use these algorithms in order to extract knowledge. And once you extract knowledge, in fact, this knowledge is represented in many different manners, and particularly in combinations of dashboards and visualizations that show the results. You can also have, for example, personal digital assistants. If you are Alexa or if you are Siri, well, this is the summit of the iceberg of all this. Okay. So you have data processing, you have a lot of people talking. You have this corpora here, you have natural language processing here, and here you have Alexa or Siri. And the important thing is that it will rely on this, but also on this and on this, in order to be calibrated and provide us with the illusion that we are talking to a real person. Of course, there are other ways of getting into action. You have, for example, perception. If you have these smartphones that identify your face, so this is also the kind of solution. And also you can have business scenarios with applications on that. So instead of having this separated, you have understood the idea is that you are going to grab all this together in many different sizes, so that people with programmers with many different requirements and computing capacities can use versions of these solutions and develop their own applications. Okay, so we have been having a look at virtualization, etc. So you are creating views and containers, well, images that become containers at many different moments, and that use pieces of all this Lego that you can have here. And this is what is a studio. Okay. And then, well, of course, either you have it on sitting in your living room, in your high performance computing system lying in your living room, or you externalize it to the cloud. And so the cloud vendors, what they are going to provide is all these as services. Okay, so you will have the infrastructure with many different hardware, with the computing and storage services, and their other high-level services in order that you can build your solutions, and then other tools that will help you, you know, have a smooth construction of your building. This is machine learning studio from Microsoft, and then the question is, if you are Microsoft, how are you going to deliver it? Are you going to deliver it in an API manner, which means that you need engineers with technical experience that will be able to deal with these APIs in order to build their solutions? Or are you providing final user interfaces, very explicit ones and comprehensive ones that can ease the configuration of such environments? Well, that's a market decision. Okay. For example, we have seen the MS Azure portal is a kind of final user solution. Of course, we have this graphic representation, and it's very easy to configure and choose with menus, etc. But in fact, if we are really going into an industrial setting, we might not be using it. Okay, we might be using the APIs and playing on terminal with that. Okay, it's just that this is a comprehensive way of having a look at that and convincing us to use their solution. Okay, so for studios is the same. So for example, today we will see the ML Studio from Microsoft that is going to be deprecated next year and or in 2 years, but that is a comprehensive solution of such kind of studio. I'm going to use it because of pedagogic reasons, but there are other interesting solutions. For example, there is Databricks providing studios of solutions, but not without nice portals that are called MLflow. So in fact, what happens is that the idea is that you have these workflows and you connect activities that will be processing data in many different manners. And so you have three main families of components: the notion of project, the notion of models in terms of artificial intelligence, okay? And tracking, because you are going industrial. And if you remember, when you studied artificial intelligence, maybe you had studied machine learning solutions, and if you remember, so you train your model, you calibrate it, suddenly you are happy and you know that your model has good performance in terms of scores. And then new data comes and the model classifies or whatever it does, okay? But then as you use it and as more data come, the performance in fact decreases. So your trained model start not being that performant when different data start coming, okay? And at some point, the performance really decreases a lot, and you have to train the model again. So this means that if you are in an industrial setting, you have to have monitors of the models that are observing the performance of the model, and they are tracking it. And then when they observe that performance has got into a specific threshold, they decide to retrain the model so that it can increase again its performance. Of course, you are not going to do it by hand, And the idea is that you can automatize this, and this is done and expressed through a workflow. And of course, here you have all the libraries possible and imaginable, including, you see here, deployment systems, so that you can provide running solutions. So this is Databricks, for example. And here is another vision of Databricks solution. So if you want to have a vertical cut, you have, your pipeline. This is what you define as data scientist, for example, or data engineer. And then you have all the backend model deployment and storing. And then you have this tracking layer that is observing how good or bad this does, and then eventually go back to the pipeline or to the training. There's somewhere there's training, and so on and so forth. And here you have all the collection infrastructure that is feeding the data on lakes or in online data reading. And at some point here, you have the applications. Okay, so you have all these in order, for example, to have your Siri on your iPhone or your Alexa in your living room. All these. And we build this. We are cool people building all this. Do you have questions until here? So to go back into professional life, a cool thing, if you are interested in this, is trying to apply to Databricks and have an internship or eventually a position in order to contribute to this. This is a cool thing to do. Okay, so again, you have a similar solution in cloud, in Google Cloud. And there is also, well, an important thing, of course, for you that are almost computing systems engineers, is try to compare. Okay, who is doing what? What are the expectations that you can have with respect to the different solutions? And in order to make decisions. Okay, so you have very complete studios, but that at some point have problems in order, for example, to deal with matrices. TensorFlow is for matrices. So if you have requirements where you, for example, if you're working with climate models or with industrial models that tend to use a lot of matrices in order to express their processing, maybe you have to think about the fact of using the Microsoft solution because your requirement is matrix oriented and it performs not very well in this kind of solution. Whereas here, for example, in Amazon, if you are not detecting anomalies, if you are not doing recommendation or ranking, but you are doing matrices, so maybe this kind of solution is for you. Okay, you have a more balanced solution with Google, and well, Watson has been having problems lately, but anyway, so you have to think about, and here is not Databricks, but you would have a look at Databricks in order to see this comparison. So it is important to make sure that that you are able to identify the real characteristics of the type of operations processing that you have to run on your data, so that you can make decisions on which are the services and the cloud provider that you are going to use in order to propose infrastructures and solutions for this type of requirements. Okay, so I'm going to show you an example of this, not that I am talking in the empty space and that you do not see this. What did I do? Yes, you probably received an announcement that I made saying that we were going to work with Azure AI. And now I'm playing with, so okay, so I shared the link to the studio. Now the studio will become service in MS Azure. So eventually, if you're interested in having a look at this, you can use your MS Azure account to play with it. But now it's engineering driven, whereas the solution I'm going to present is a final user driven solution. So the idea is that they created a community, think about Kaggle, okay? So a community of projects devoted to data science, but where you are going to, of course, develop the project, use predefined tools of all the tools that you can imagine in a graphical way, and you are going to be able to observe not only the specification of your workflow, but also the results in technical in a technical perspective. Okay, so how long did it take to execute each task of your workflow, and then which were the resources used in order to execute it, which were the data that were produced between one activity and the other. Okay, so technical and non-technical observation of your project, which is a data science project. And then once you experimented and etc., you publish this kind of result. So in the result, so you are going to reason about experiments. First important thing to consider is that experiments are first-class citizens. Okay, so you can reason about an experiment, you can modify your experiment, etc. Okay, so you can manipulate an experiment as if it was a digitalized object as a class, okay? And the experiment has a textual description, that has an interface, okay? An external interface. For example, here, the problem was to demonstrate and demand estimation using regression of UCI bike rental data, okay? So, I don't know how, yes. So you have the description more or less as in Kaggle. You have, we are going to see it in a moment. So this is the workflow that implements the solution to the research question that they have, okay? And then they develop all the different steps that they performed and that they used in order to decide how to design these pieces of activities within this huge workflow. And then, of course, they discuss results, and particularly another thing that they do is that they explain how they specify this, okay? And beyond that, if you click on Open in Studio, you land here. And here you have the studio. So just to give you a tour on the studio. So you can have data sets. So you can have your own data sets. So you have like resources, okay? So you have data sets already to use, or you have your own data sets, okay? So you have here anything you want, okay? More or less as in Kaggle. But in Kaggle you don't, and here you do. You have trained models. Okay, for example, regression, for example, k-means, for example, SVM, etc. So I'm supposing that you remember your studies in artificial intelligence. Okay, so you can have other types of operations. For example, if you are dealing with graph data, you can have all the different operations that you can apply to graphs. For example, you can compute betweenness, closeness, eigencentrality, format conversion, because graphs are represented in many different manners, so you can convert them into specific data structures. You can have global metrics, hubs and authorities. This is to identify communities, compute the degree of the nodes, do page ranking. Okay, so these are algorithms ready to use. And if you have your own algorithm, you can implement it and then upload it here so that it can be used in your studio. Of course, there is a lot of data format conversion. So this is something, for example, that you cannot find in Kaggle. If you want to convert to CSV, to a specific format, these different formats, you can get the data set, convert it, and then produce a new data set. Of course, you can enter your data manually, export, etc. So everything that has to do with archival. Again, a lot of processing. So the type of operations that we did in Kaggle, filtering, etc., we did with pandas and with statistics. You can do it here with these predefined things. You can seek for filtering, I mean for features. You have machine learning. So you see statistical functions. If you are dealing with text, you have text. If you are dealing with time series, you have. And then, so everything, like all the tools possible and imaginable in order to deal with it. And then what you're going to do is that dragging and dropping, you are going to define your workflow. So I'm going to do a little bit of zoom in here and then so, for example, in order to estimate the demand of bicycles in the city, we are going to use first a data set about bike rental in the UCI data set. Then we are going, and these are operations from here, okay? We are going to create a lot of metadata regarding weather conditions and seasons, and we are going to complete the rental data set with external data that will include this information to the initial data. Then, instead of using all the CSV, we are going to select a set of columns that we do not want to use in our experiment. So we are selecting, removing timestamps and all columns that are part of the label, etc. Then we are going to execute an R script. Another important thing is that the operations can be implemented in any language you want. Since they are grabbed as a service, you do not care what is inside, okay? And here important to see is that here these little dots are in fact IO, and you can define restrictions on the IO. right? And once you do this, well, I'm going to try to run this. I'm not sure what is going to happen and how much it is going to take. Behind, of course, you have guessed that is the cloud. So, well, so it has started at this time, it's running, and then I will wait for a while in order to show this. So I'm going to leave it running here. At some point when it will stop, I will attract your attention on the results. So if you, I'm going to zoom in here, just to let you see. You see at runtime. So you have these little dots saying that these activities have already been executed. Can at some point, no, not now. At some point, it will provide me with the details, execution details of every activity that it runs. And so I can store my workflow. I can store the execution log of the workflow and share it to the world, analyze it, and eventually modify certain pieces of the workflow and try it again and again with just clicks. Okay. So of course, this is not an industrial way of doing the things, but this is more for testing, okay? If you are a data scientist, you do not want to program, you are going to connect your boxes, etc. You are going to have a try, you are going to estimate time, etc., IOs, and then once you are sure that you are ready to with this solution, then you can move to, well, in ML Studio, you can move to tracking, you can move to grab your solution into a service and deploy it on Azure, for example, so that you can use it on top of, and you can put applications on top of it and start using it as a service. So you have all the life cycle of the production of this kind of solution in one integrated infrastructure called a studio. Okay, questions here? Yes, please.
Okay, so just so this, for example, this editor, it helps us to create like, well, machine learning models,
Machine learning pipelines.
pipelines. Ah, okay.
So from the data cleaning, you remember the workflow that I showed at some point, where you have cleaning, preparation, trains, fragmentation of data, train, then choosing a model, etc., and then tracking, and then using tracking that I didn't show in my workflow, and then maintaining it. It has finished.
Ah, okay.
You see, um, I'm trying to open them. No, here no details. Status details no. I don't remember how to. Yes, here. Well, I'm going to start with the first one. I can, for example, see the log of the of each box, you see, and here you have when did it start being executed, the duration of the execution of the box, everything that that was produced, etc. The result data set produced. So this is the model. In fact, this is the regression model. And then at what time did it stop, and etc. Okay, at some point it also provides you with the resources it consumed. And so for every, and here you have a comprehensive aspect to see. So you see the type of data, whether it was categorical or not, the moment in which start, the duration of the execution, and whether there were details or not for each box and for each element of your workflow. And so what do I need this for? I'm going to give you an idea. In my research, I work with something called just-in-time architectures. And in just-in-time architectures, the idea is that you build on the fly a cloud architecture. So you have your pipeline, like this one. And then when you start executing, it will create a view of the cloud with, it will decide, for example, whether for which activities you need a GPU, a CPU, or any other hardware, whether you need specific storage or specific types of memory in order to deal with your data. So it's like creating the virtual machine that we created before running our experiments. It creates that on the fly according to the workflow, and so you have dedicated cloud solutions for them, for your data. Okay? And so what we did is the following. We used these many examples of these pipelines, and we calibrated an infrastructure that we have in order to estimate the type of resources that you need when you have specific logs. Okay, and so we used artificial intelligence in order to estimate and then make decisions on the right type of components that you need in order to have the right architecture for the right pipeline. And so all this information generated here served as input in order to make decisions about the creation on the fly of these just-in-time architectures, and then also to decide whether to execute these pieces of this workflow on the back end, so on the data center, or on the edge or on the fog, in order to reduce economic cost. And this thanks to this information created by this workflow. So this type of things you can exploit. And well, if you are a data cloud provider, this helps you estimate the number of resources that you need in order to execute your workflows. So in this spirit, this can be interesting. Other questions? Okay, so this was the ML Studio moment. Again, in order to go into details about this, well, we would need a whole semester to really go into details, etc. But I wanted to show two things: that it is possible to have ready-to-use infrastructures in order to provide big data management solutions and big data processing solutions. Okay, so that's first thing. Second thing is that to make you aware that this kind of studios exist and that it is possible to contribute to the construction of such studios. Okay, so that's another, to show you another professional perspective that you can think about if you are interested in this type of problems. Okay, and the third thing that you have to, in the idea of comparison, that you have to consider the different providers that you have with respect to your requirements in order to choose the best provider possible according to this. So that's the message I wanted to deliver with this general view of the ML Studio. Okay. So if there are no questions about this, I have an activity to propose. So with this, I close infrastructures, okay, and infrastructure delivery. And now to grab the lab, I want to work with you in the preparation of your final work. Yes, I can still share. Where did I put this? Of course, I have a festival of things right here. So as you remember, for the final work, you have to prepare a medium entry and a video. Okay, so I wanted particularly to work with you to give you input about the medium entry. The medium entry is an individual task, but here the idea is that we work together in order to run a set of teasing questions that I am proposing in order to start figuring out what you can say in such medium entry, okay? So the idea is the following, is that, well, you are going to organize in groups of 4 or 5, and you are going to, as we have done in previous exercises, you work in this document, okay? And the teasing questions are the following. The idea is to think and consider using cloud computing and big data for designing the new normal. Okay, so we are going to invent a new society, a new world, nothing that we have seen before. Okay, and we are going to consider the following aspects. Of course, technical aspects, because we are computing systems engineers, we like that. And with respect to technical aspects, we are going to think about what are challenging problems that should be considered for building data-driven solutions. Okay. And make underlying cloud infrastructure evolve to make it possible for people to deal with huge amounts of data for their good. Okay. So you can think about any society problem. For example, I don't know, how would you help immigrants traversing from the central part of America into the States, such in order to, I mean, you are not going to avoid immigration, but make their life, this horrible traversal less painful. Right? Or how would you figure out some solution in order to ensure a better, smart barrio for example, in Ecatepec. Okay, make people's lives better thanks to data and cloud accessible to this type of communities. Okay, how would you do that? Technically speaking, okay, are you going to use used devices and reuse them in order to give them connectivity? Are you going to do like Elon Musk and have these balloons of connectivity or this satellite connectivity in order to provide them and not wait until cables are deployed or antennas are deployed to let them connect? These kind of things, okay? You should also think about ethical and sustainable aspects. What are the ethical issues, but not security and privacy, those we know, okay? To be considered when developing data-driven applications on the cloud. How cloud-based big data solutions harm the planet, and how can we reduce this harm, technically speaking? Okay, so we are consuming like crazy. Okay, how do I reduce my consumption but still access to services and avoid harming the planet? So all this is technical, okay? So it's not like asking the piece of the world, how are you really going to do that? And finally, how can cloud and data seen as resources be accessible for avoiding what we call epistemic violence? Epistemic violence means ignoring knowledge and accessibility on resources produced by countries or communities that are not in power, okay? So how do you make Africa, not to talk about Latin America, access to cloud resources as if they were in the US? Okay, so these are the teasing questions. And the idea is that you organize in groups of 4 or 5 and you brainstorm, okay? So what you are going to put in this document is brainstorm, okay? Anything you want to answer this. You can choose one of them, some aspect of them, or all of them. It depends on what you like. And you can draw, you can look for infographics, you can find examples, images, or other media to help illustrate your ideas, okay? And then once you have brainstormed, you wrap up your ideas in a Google slide deck of 1 or 4 slides, and you share them on Slack, the link on Slack, okay? So you have to be very agile, but still try to figure out the points of view that you could use of these teasing questions, and that can help you as entry, as motivation in order to eventually write your medium entry. Is this clear? Is this crazy? Yes. Is this clear? I don't know. Please.
Yes, sorry, Circuit. It's just that, so we have to do like a cloud computing solution for the new normal, right? About COVID? Or sorry, just that I didn't
A
hear.
new normal.
Okay.
Anything that you consider new normal. Pandemic is an example, but it's not the only one. You can use another one. Yes, please. Alexander?
Thank you, Doctor. I wanted to ask, when shall we share the link to our slides on Slack? Is there a limit? Is it today?
I mean, you can, yes, I mean, either today or, I mean, during the week.
Okay.
I mean,
during-
today I thought that I would use less time, so I was thinking about today. But I mean, feel it not as a next like a homework, but rather that's something that I can have a look at and then maybe give you hints to help you decide how to write your medium entry. Okay.
All right. Thank you very much, Doctor.
You're welcome. While you are thinking and organizing, for example, I once had a student that wanted to invent access to connectivity, to smartphone connectivity through publicity. So the idea was that, well, if you do not want to invest your money in buying uh, a provider, a connection provider, you accept receiving publicity in your telephone, and depending on the publicity that you accept to receive, you will have a bandwidth. So, for example, if you go to a mall, you say, okay, I'm going to accept receiving offers about the different stores here in the mall, and in exchange to this, I will have access to Wi-Fi. And so it's gratis, no? Well, of course, it's not gratis. The provider, it is the stores that provide publicity. It's more or less like on TV, no? Um, Companies pay for publicity, and they fund a little bit of the transmission of national TV, for example. So in that way. So it was to figure out an alternative for connectivity, like. So what it would be interesting to have is like at least organize your groups and write the names of the people that you are working with in the group. Because I mean now it's 18:30, so we should wrap up. But at least that I see that you have already organized into groups, and then afterwards you can continue asynchronously to start looking at the teasing questions and finding information. If you remember, for example, you can organize as the groups we used for Kahoot, for the Kahoot exercise, or I let you choose. So I let you write the members of the group, and then we end the session. And have you met in person among yourselves? Do you know yourselves in person? Okay. Only a few. Okay. On Saturday, come yourselves so that we can take a photo of the group and myself. And if you meet me somewhere in the world, you say hello. Yes. Well, you know my face, but I don't know most of your face. I see your photos, but photos are not contractual. Maybe you look uglier or more handsome than you look in your photo. Yes, of course. But you cannot say that I told you before that you should prepare for the photo to make sure that you prepare your face for it. Okay, how many are we? 1, 2, 3, 4, 5, 6, 7. And how many? So we are, come on, those that are missing, put your names. Poor Alexander, he's alone.
No, my teammates are in the next page.
Ah, okay, sorry.
No worries.
Okay, so we are all together now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17. So there's on, no, because it's 18 because I'm connected twice. Okay. So everyone has a team, right?
Right.
Good. Very good. So asynchronously, next step is brainstorm. So do not do beautiful things. Just put choose some aspect of the teaching questions. You write them in the document, and then you feed with some material, right? And then afterwards you prepare your. But that's asynchronous, right? And then from now to Friday that we have the regular course, I can have a look at what you have shared, prepared, etc., so that I can give you feedback. And then please survey the Slack, because in the period in which we won't have class and that you will be preparing your final work, we can interact on Slack so that you do not feel alone preparing the final work. Okay, so I'm going to stop here so that you can go to the other courses, classes, activities, and I'll see you on Friday. Stop sharing. Nice day to everyone.